Now let's go ahead and take a look at example number 5. I again want to use properties of integrals to try to determine whether the value of this integral, and gosh, look at the craziness of this function. I want to determine though if this integral is going to be positive or negative. Now I'm going to do this without ever even understanding what the graph of this function looks like. In fact, that's the point, right? Is that if I can't see what this actual area is, I can still try to determine if it comes out positive or negative. So in order to do this, it will be helpful again to go ahead and consider my comparison properties. I should recall that if I can confirm that this function only spits out positive y values on an interval, then its area under it must be positive. However, if it spits out only negative y values, then the area would be negative. If it spits out values that are negative and positive, then that's going to be a little bit more complicated to work with because I'd have to determine whether the positive portion is bigger or the negative portion is bigger. So let's hope for one of the first two cases and see what we have. All right, so I'll note first, note that our value of x is actually going to be existing purely between -2 and 2. Okay, so if x is in this interval, so I'll say if this is true, so if I have a value of x in there, then let's take a look at the numerator of our fraction. If I was then to do x to the third power minus 9, could I guarantee you anything about the result? Well, notice if I cubed a negative number in here, I would just get something negative minus something that's negative. Or, sorry, minus 9, which would produce something that's negative. If I plugged in 0, clearly I get something that's going to be negative. 0 minus 9 is negative. And even if I went all the way up to plugging in the value of 2, I would get 8 minus 9. That's still going to be negative. So I can guarantee that x cubed minus 9 is still going to be a negative value. It's going to be less than 0. So let me rewrite this one more time. If what I have above is true, then definitely x to the third minus 9 will be less than 0. Now what about in the denominator? Well, in the denominator I'm always going to be taking the absolute value of x and then adding 1. So whether I insert 0 or a positive number or a negative number, this denominator is clearly always going to be greater than 0. Well, if my top of my fraction is always negative, no matter what I plug in, and the bottom of the fraction is always positive, no matter what I plug in, then I could definitely see that x to the third power minus 9 over the absolute value of x plus 1 would have to be negative on the interval from -2 to 2. I have to know that this function from -2 over to 2 exists, say, somewhere down here. And if that's the case, then certainly the area under it is going to, or the area between it, I'll say, between it and the x-axis, is going to ultimately be negative. So we can conclude that the integral from -2 to 2 of x to the third minus 9 over absolute value of x plus 1, I don't know what the value is, but I know it's not 0. I know it's not positive. It must be a negative value.